what I really need to solve for is, I'm going to write this over here, t squared minus 2t minus 4 equals 0. And again, we're going to have to put it into the quadratic formula. So again, I'm rushing, but so if b is negative 2, the opposite of b would be positive 2. And then plus minus the square root, b squared would be 4 minus 4 times a is 1, c is negative 4. Multiply that, you get negative 4. Over 2 times a, and a is 1, so we'd get 2 at the denominator here. Simplify your radical, and we get 2 plus or minus square root of 4 plus 16 is going to give us 20 over 2. Now earlier in the last problem we had the quadratic formula. I said we didn't have to simplify the we didn't have to simplify the radical. And because this is a application problem, you could just plug this in the calculator, get your two values. Now there will be two values because you would have 2 plus the square root of 20 divided by 2, and then 2 minus the square root of 20 divided by 2. But let's pretend just for a second this was something that you had to simplify the radical, since we haven't really done that with a problem. If we simplified this radical, do that off to the side, the perfect square that's a factor of 20 is 4. So the square root of 4 is 2, so we get 2 square root of 5. So if I rewrote this, I would have 2 plus or minus 2 square root of 5 divided by 2. So I could divide or reduce all of these terms by 2. Or I could factor out a 2 from the numerator, which would give me 1 plus the minus the square root of 5 divided by 2, and so then you can see the 2 reduces. So in simplified radical form, your solution would be 1 plus or minus the square root of 5. However, this is a question about time, and I'm not going to tell you that it landed on the ground at 1 plus or minus the square root of 5 seconds. So this would be a problem that you'd probably substitute in the calculator and get a value. Now we could eliminate the negative because, again, time is something that has to be positive. So if you took 1 minus the square root of 5, you're going to get a negative number. So we can eliminate the negative choice and just take 1 plus the square root of 5. So I'm going to rewrite that up here. So x equals 1 plus the square root of 5. So if I plug that in the calculator, I got a value of approximately 3.24 seconds. So I rounded to 2 decimal places. Okay, so then the next one, they want us to know what time will the rocket be at a height of 22 yards. So for this one, instead of setting the equation equal to 0, we're going to set the equation equal to 22. Now when you solve an equation by factoring or with quadratic formula, you have to have it set equal to 0. So we have to subtract 22 to get 0 on one side of the equation. So when I rewrite this equation now, I have a c value now of negative 2. And again, this is one that we're going to have to use quadratic formula to solve. And I have done that on a separate sheet of paper. So I'm just going to kind of put my other sheet of paper here. So going through this, I plugged it into the quadratic formula, and when I got to this point, I then figured out, I took my calculator and I took negative 10 plus the square root of 60, hit your equals first, and then divide by negative 10, and I get 0.23 seconds, and then negative 10 minus. So negative 10 minus the square root of 60 divided by negative 10 would equal a positive 1.77 seconds. So why are there two solutions? Well, let's think about it. If you go back and look at the graph that I had drawn, if 25 is the highest height, then wouldn't it hit 22 somewhere along the way up and somewhere along the way down? Yes, so there would be 2 times at which it would be 22 feet high. And those 2 times are at approximately 0.23 seconds and 1.77 seconds. All right, so that concludes my ISTEP review. Good luck. Hope everyone passes. Hello, one more time. We're finally doing the last section. I'm going to try to move through this a little bit quicker because I have spent way too much time on this already. Okay, one of the standards that we want to cover today is whether or not you're able to identify if you're given a situation, if something is going to be linear, exponential, or quadratic. So in these different situations, we want to see whether or not if it's linear, then the graph will have a constant rate of change. If your graph is, or situation would represent an exponential, this is supposed to be function, then it would have a rate of change that would increase. So we'll see. You'll see in some of these examples that I get later on. All right. So if Mike earns $10 per hour, this is actually going to be a constant rate of change because every hour. So if we have the number of hours, and we have the total, amount earned. If Mike earns works 1 hour, he's going to earn $10. If Mike works 2 hours, he's going to make $20. If he works 3 hours, he's going to make $30. So if you look at the rate of change in the y values, they're all increasing by the same amount, $10 per hour. So constant, so the same increase, same amount of increase every hour. The same thing is going to be true now with the water in the bathtub. So they're even telling us the water in the bathtub decreases at a constant rate. So again, if it's decreasing at a constant rate, a graph would sort of look like this, where if this was the level of the water in the bathtub, it would be decreasing at a constant rate. So it's not going to be wavy or up or down. The next one, though, is going to be exponential, and the reason is because you've got a value of a car that is depreciating by 9% each year. So I'm going to try to give you an example with a table so that you can kind of see what's happening when the car depreciates by 9% each year. So let's say on the left I have my number of years, and on the right side of my table I'm going to put the value of my car. So at year zero, let's pretend that it was worth $10,000, and I just used 10,000 because it's easy to figure out 9% of that right away. So 9% of 10,000, if I decrease that $10,000 by 9%, 9% of that $10,000 is $900. So if that value decreases by $900, then my new value after year one is $9,100. Well, in year two, so this is 9% of 10,000. In the next year, it's going to be decreasing 9% of the 9,100. And I've already done the calculations, so it's going to be decreasing by $819. And again, that's 9% of 9,100. So the rate of decrease is getting smaller, so it's not a constant rate of change. So then you would get a value of $8,281. And then if we just go one more time, if I take 9% of the $8,281, that will be depreciating by $745.29, which is 9% of the $8,281. And that will then equal a value of $7,535.71. So that's after year three. So you can see that the amount of decrease is decreasing itself. So this is what we would call an exponential decay problem. So it is exponential, and it would also be exponential decay since the rate of change is getting smaller each time. Okay, the next two problems, Sue decreases her, so again we got cars going on here. So Sue decreases her selling price of her car by $50 each week. So again, if we think about whether or not this is going to be the same every week, well, after 1 week, so again, if we could maybe do a table with the number of weeks and the selling price. So after, let's say she's selling her carts for $1,000. So after 1 week, now it's going to be $950. After 2 weeks, $50 less, it will be $900. After 3 weeks, it'll be $850, and so on. So you can see that there's a constant decrease of $50. So since there's a constant rate of change, that would be a linear equation. So going back to this one, this is also linear, and this one is linear. So A was linear, B was linear, C was exponential, and it was also decay. And then E, you've got Tia, who's decreasing the selling price of her car by 5% each week. So this situation would be similar to the situation that we had here. Since you're decreasing by a percent, that percentage is going to change every time. So just even though the percentage is the same, what you're starting with, or what you're taking 5% of, is going to change. So every time we subtract 5%, you're going to have a new number to take 5% of. So this one is going to be exponential also, and it would also be exponential decay, just like the problem C. Okay, the last example here, F, we have a number of views. So, and X represents the number of days after it's been uploaded. So on day 0, so this is on the day it was uploaded, there were 10 views. And then 5 days later, there were 253 views, which is an increase of 243. Then after 10 days, there was it now has 59,059 views. So that is an increase of 58,806. So you can see that the rate of change is definitely going up. So this is by quite a lot. So this will be what we call exponential also. But because the rate of increase is getting bigger, it's going to be exponential growth. All right, so that's really all that we're going to cover with the exponential equations. The rest of these problems are all quadratic. The first problem here, so we've got 5 problems here that are quadratic and that we have to solve. So when you're looking at quadratic equations, we've got different methods. You want to look for, does it have an x squared term, and does it have an x term and a constant? So in this problem, you have an x squared term, but these two are constants. So the easiest way to solve this one would be using square root method, which means I'm going to get x squared by itself. And when I divide by 3, I get 64 is equal to x squared. Then I would take the square root of both sides, and I would get both a positive and a negative. So when you're taking the square root of both sides, you're going to get a positive and a negative value, because it's an even root of 8. So if you were to substitute positive 8 or negative 8 back into the original equation, it would give you a true statement. So they both are solutions. All right, number 2, or B, you have an x squared term and an x term and a constant. So in this case, I'm going to try to use the factoring method. We cannot use the square root method unless you have just x squared terms and constants. So like problem D down here, this would be a good one for using square root method. But once you have an x squared and an x, you cannot use the square root method. So I'm going to try factoring, but before I can factor, I have to get this equation equal to 0. So I would add the 15 to the other side, get x squared plus 8x plus 15 equals 0. So then I'm going to try to factor this. Well, let's think. Are there two numbers that multiply together to equal 15 that add up to 8? Yes, 5 and 3. So when I factor it, it would factor into x plus 5 and x plus 3. And then once it's factored and set equal to 0, we can set each little equation equal to 0 and solve each one. So that's going to give me x equals -5 and x equals -3. So both of those numbers, if I were to substitute them back into the original equation, they would be solutions and they would work. All right, letter C over here. So letter C, again, we've got an x squared and an x term. So we want to get everything to the same side and set it equal to 0. But I also want to keep the x squared term, or the leading coefficient, positive. So I'm going to move the x and the 5 to the left. So when you move terms from one side of the equation to the other, they basically change sign. Like this -15 here. When I moved it to the other side, it became positive. So I'm going to do a little shortcut here, and just, if you look at that -x that's on the right side of the equals, when I move it over to the left, it's going to become positive x. When I move that 5 to the other side of the equation, it's going to become -5. Okay, so there's a number in front, which means I can't use my basic factoring skills. I mean, you could use guess and check, but I would try to use AC method with this one. So if I took my 2 and my -5 and multiplied them together, which would be my AC, that would equal -10. So just like before when I was trying to find two numbers that multiply together to equal 15 that add up to 8, I want to do the same thing, but instead of using -5, I want to use -10. So will there be, or are there two numbers that multiply together to equal 10? Because it's negative, they'd have to have different signs, so they would have to have a difference of 1. Well, no, they don't. There aren't any factors of -10 or 10 that have a difference of 1. So factoring is not an option. That means we have to use our quadratic formula. So our quadratic formula will be given in the reference sheet, but the formula says x equals -b plus minus the square root of b squared minus 4ac. Okay, this is a mess. Yeah, I think I can do better with that. So the formula x equals -b plus minus the square root of b squared minus 4ac all over 2a. All right, so looking at our equation here, the a, b, and c are your coefficients of your trinomial here. So the a value is 2, the b value would be 1, and the c value would be -5. So now it's just plug and chug. So -b, think the opposite of b. And some of this I'm just going to shortcut. I'm going to do a little bit of the math in my head. So -b, think opposite of b. Well, if b is 1, then the not opposite of b would be -1. Plus minus the square root. If I take b and square it, or my 1 and square it, I get 1. And then minus 4 times AC. Well, A is 2, C is -10, so if I multiply those together, I get -10. And then that whole thing is over 2A. So if A is 2, 2 times 2 would be 4. So now I'm going to simplify my radical. And I'm going to, so you have to multiply first. So the -4 and the -10 multiplied together would be 40. So it would be 1 plus 40, or the square root of 41. Now, what's nice about this is 41 cannot be simplified. There are no factors of 41 that are perfect squares, so we would just leave it probably in radical form. And your solution then would be -1 plus or minus the square root of 41 over 4. So that's what x equals. That's how you would solve a quadratic equation and leave your answer in radical form. Now, if this was a application problem like we're going to be doing on the next page, you're going to want to actually plug the value into the calculator and round to maybe the tenths or the hundredths, whatever they ask. But since this is not something that applies to a real life situation, we're going to leave it as exact and as we can, and we're going to leave it in radical form. All right, the next one, like I said before, when you have an x squared and a constant, the easiest way to solve this would be to use the square root method. But before using square root method, you want to get the x squared term by itself. So I will divide 9 first, and then I will have x squared, and I want to leave this as an improper fraction, 169 over 9. So the next step then would be to take the square root of both sides of the equation. Once again, when you take the square root of both sides of the equation, you're going to get two solutions, the positive and the negative. Well, what's nice about both of these numbers is they're both perfect squares. So when you take the square root of 169 on the top, you get 13. If you take the square root of 9 on the bottom, you get 3. So the solution to this would be positive and negative 13/3. All right. And the last problem, E, again, it has a coefficient in front. You got an x squared term and an x term, which means we're going to either have to factor or use quadratic formula. But I'm going to try to see if the AC method will work. So let's multiply our A and C together. We get negative 24. So now think, are there two numbers that multiply to get together to equal 24? Since it's negative, the numbers are going to have a difference of 5. Well, yeah, 8 and 3. So since I know that's going to work, I'm not going to factor it right away. I'm going to take it from 3 terms to 4. So I'm going to take this 3x squared and bring it down. So I'm going to get 4 terms here. So the first term and your last term stay the same. And again, this is AC method. You could try guess and check if that's something you're comfortable with, but I like to teach the AC method because it always works. All right, so bring your first term, your last term down, and then like I said earlier, the two numbers that multiply together equal 24, that subtract to equal 5 are 8 and 3. But in order for these two middle terms to give us a positive 5x, you have to have a positive 8x with a negative 3x. So you have to fill in the x's and you have to fill in your signs so that it will equal that 5x. Now we're going to factor by grouping. So when you factor by grouping, you separate the first two terms from the second and factor out whatever you can from the first term, or the first two terms, which will be x, which leaves us with 3x plus 8. And then over here, we want to factor out something so that we end up getting the same thing as we had here. So if we had a 3x plus 8 and we want to get a 3x plus 8 here, we're going to have to factor out a negative 1. So now, if you look at these two groups, what do the two groups have in common? The 3x plus 8. So I'm going to factor that out from each group. And then when I factor that out, the x minus 1 is left in parentheses of its own. So if you're not sure whether or not this is correct, we can double check. 3x times x is 3x squared. 3x times a negative 1 is a negative 3x. 8 times x is 8 times x is positive 8x, and then 8 times negative 1 is negative 8. And if we put that together in the middle, we would have what we started with. So now we have to finish solving it now that we've factored it. To solve it, just like the factory method problem up here, once you've factored it, you set each little equation equal to 0. That's called the zero product property. And if we do that with this one, 3x plus 8 equals 0, and x minus 1 equals 0. This one might be a little bit harder to figure out, but you would have to subtract 8 and divide by 3, which would give you x equals negative 8/3. And then this one you'd have to add 1, and you would get x equals 1. So those are your two solutions, and that's the end of this page. So now we're going to move on to the next. And we have a problem that is, so we got a lot of word problems on this side. So you've got a rectangle that has an area of 104 inches squared. It has a width that is 5 inches less than its length. Okay, so that's the information they're giving us. They want us to write an equation representing the area of the rectangle. So we're writing an equation to represent the area of a rectangle. Well, what's the formula for the area of a rectangle? Area equals length times width. So what information now can we substitute into this formula? Well, they told us the area is 104 square inches. So I can put 104 in the place of A. And then over here, we got another piece of information. It's telling us to use x to represent the length of the rectangle. So I could put x then in place of my length. And then one more piece of information, it tells us our width is 5 inches less than its length. So the width equals, so you're taking 5 away from the length. So if you can either think of it as L minus 5, however, since the length, we're using x, x minus 5. So the width is equal to x minus 5. So I can now multiply by x minus 5. And because that's a binomial, you want to put it in parentheses. All right, so here's our equation. That was what they asked us to do first, write an equation. All right, so now what are we going to do? We're going to solve your equation for all the values of x. Okay, so let's take it off to the side. 104 equals, and I'm going to distribute the x here, which gives me x squared minus 5x. And just like the problems on the other side, when you have an x squared and an x term, you've got to get this one side equal to 0. So I'm going to move this 104 to the other side so that I get 0 equals x squared minus 5x minus 104. Now I'm going to try to factor it. Now I don't know all the factors of 104 off the top of my head, but what I like to do when I don't know all the factors off the top of my head is I make a list. So and I always start with 1 and the number itself, and then I would jump to 2. Well, 2 goes into 104 52 times. 3 doesn't go into it. 4 would go into it. Have it written down somewhere. It's 26 times. And then if I try 5 and 6 and 7, none of those numbers go into 104 evenly, but 8 does. 8 goes into it 13 times. And if we're looking for two numbers that have a difference of 5, 8 and 13 will work. So this can be factored into x. And now think about your signs. If we want them to multiply together to equal a negative, the signs have to be different, but your larger one will be negative. The larger number needs to be negative so that it will end up giving us a negative 5 in the middle. So negative 13 and positive 8 will work. So if they multiply together, you'll get a negative 104, but if you add the negative and the positive now, you get a negative 5. So just like before, if we set each one of those equations equal to 0 and solve, your solutions would be 13 and negative 8. Okay, so those are your possible solutions. However, think about what the context is. What does x represent? X represents the length of a rectangle. So can a length be negative? No. So we're going to eliminate that choice. So logically, x can only be 13, or the length can only be 13. So use your solution to the equation to identify the width and length of the rectangle. So x is our length, so the length then is going to equal 13 inches. Since your width was 5 less than the length, just subtract 5 from 18 and you get the width is going to equal 8 inches, which usually ends up being the opposite of what your other solution was. Okay, so explain how you determined which value of x to use. Well, we had to use the positive value because the length cannot be negative. So since a length can only be positive, x must equal 13. It cannot equal the negative 8 because it's negative. The length can only be positive. All right, so in the next one here, they're asking what are the zeros of the function. So zeros is a term that you really need to know what that represents, because zeros just mean x-intercepts. So if we were to graph a function and wherever it crosses the x-axis, that's called a zero. Well, one of the reasons why it's called a zero is because all x-intercepts have a y-coordinate of 0. So the y-coordinate for all x-intercepts is going to be 0. So if we were to take 0, which is our y-coordinate, and put it in our equation for y, we then will just have our equation. Basically, we want to set our equation equal to 0. Equal to 0. Equal to 0 and then solve. So whenever you are given an equation and you want to find the zeros of the equation, or the function, sorry, whenever you're given a function and you have to find the zeros of the function, you want to set the equation equal to 0 and then solve it. So x squared minus 8x plus 15 equals 0. And this one is a pretty easy one to factor, but be careful, your signs have to be the same in order for this 15 to become positive, but they're both going to end up being negative. So x minus 3 and x minus 5, so that they would multiply together to equal a positive, but they would add up to the negative 8. So your two solutions then would equal a positive 3 and a positive 5. So that means now be careful, x-intercepts are points. So depending on how the question is worded, or you should write them as ordered pairs because these are points. So 3 is the x-coordinate for one of your points, but the y-coordinate is 0. And you're going to have a second x-intercept, or 0, with the x-coordinate of 5 and a y-coordinate of 0 again. So these are our zeros. If you were ever given a graph and you're asked what the zeros are, simply look at where the graph crosses the x-axis, and those will be your zeros. Okay, the next one here says to determine the line of symmetry, and I believe we have a typo here. This instead of maximum value should say minimum. And the reason I know that is because if I look at the equation, the a value is positive, which means that the parabola has to open up. So if I were to sketch a little graph of this, 1, 2, 3, 4, 5, 6. Okay, so our parabola would cross the x-axis, positive 3 and positive 5. Its vertex would be down here, and then it would be going up like that. Because it has a positive a value, it should be opening up. So in order to figure out what the minimum, well, we've got two things going on. Line of symmetry. So your x-intercepts have to be symmetrical about the line of symmetry. Parabolas and quadratic functions are symmetrical. So there's going to be a line of symmetry that goes through the center of your graph. Well, since this is at 3 and this is at 5, the line of symmetry has to be going through at 4, since both 3 and 5 are exactly one space away from that. So your line of symmetry has to be the equation x equals 4. Now, there's a lot to be said about this line of symmetry. You're given an equation probably on the reference sheet that says the axis of symmetry, so line of symmetry or axis of symmetry, same thing. They tell you x equals negative b over 2a. Well, just like our quadratic equation, the b and the a come from our equation up here. So our b is negative 8, our a value would be 1. So if I were to substitute negative 8 and 1 into this little equation here, I would get negative 8 because it's opposite. So b is negative, so I would be taking the opposite of b. So that would be a double negative over 2 times a, which is 1, which would give me positive 8 over 2, which equals 4, which is exactly what we had there. The other thing that's nice about the axis of symmetry is that it always goes through the vertex of the parabola. So we know for sure that the parabola has an x-coordinate of 4, or the vertex of the parabola has an x-coordinate of 4. So how then can we find the y-coordinate? Because when they're asking for the minimum or maximum value, that's what they're asking is what is the lowest y value on the graph? Or if the graph was opening down, it would be what is the highest y value? So we have to find your minimum and maximum value always equal the y-coordinate of the vertex. So in order to find the y-coordinate of the vertex, simply substitute the 4 into your equation, or if you can figure it out on the graph, it's actually going to be negative 1. But if you're not sure, plug 4 into your equation, So I would take, so my equation says y equals x squared, so I'm going to put 4 in the place of x and square it, minus 8 times 4 minus or plus 15. So when I take 14 and square it, I get 6. Negative 8 times 4 is negative 32 plus 15, which will equal negative 1. If I took 16 minus 32 plus 15, it would equal negative 1. So that is the y-coordinate of my vertex, and that is also my minimum value of the graph. So the minimum value equals negative 1. All right, then we have one more problem to go. And this one is a little bit more complicated. We have a model rocket that it's fired into the air from the top of a building. The height h above ground is, so h is representing the height above ground in yards, and t represents the seconds is given. So rockets do go up pretty fast, and this is our equation. So they want to know what the maximum height of the rocket is. So we've got a negative leading coefficient, which means our parabola is going to be going down, which kind of makes sense. If you have a rocket, it's going to start from the ground, go up, and then come down. So it would make sense for our parabola to be going down, opening down. So your vertex would be the highest point on the graph. So how do we find the maximum or the minimum? Just like before in the last problem, the maximum or minimum is always the y-coordinate of the vertex. Okay, well, in this equation, we don't necessarily know the vertex. It's not in vertex form. So in order to find the y-coordinate of the vertex, we first have to find the x-coordinate of the vertex. So we're going to use that equation again that says the x-coordinate of the vertex, or also your axis of symmetry, is x equals negative b over 2a. Again, negative b means the opposite of b. So if b is 10, the opposite would be negative 10. And then 2 times a is negative 5, so 2 times negative 5 would be negative 10 again, which gives us 1. So the x-coordinate of the vertex is 1. So now we need to find the y-coordinate. So if we substitute 1 into the equation, well, 1 squared is just 1 times negative 5 is just negative 5. So h of 1 is what we're actually doing. We're substituting it 1 into the equation. So negative 5 times 1 squared plus 10 times 1 plus 20. So again, I said 1 squared is 1 times negative 5 is negative 5. 10 times 1 is 10, and then plus 20. So we've got negative 5 plus basically 30 is going to equal, so h of 1 equals 25. So what have we really found? What does the input represent? Well, that's the t value. So what does t represent? Seconds. So after 1 second of the rocket being shot in the air, it has a height of 25 yards. And that is going to be the highest point that it's going to reach. So the highest or the maximum height of the rocket is going to be 25 yards. All right, so we found our vertex. Now we want to know, well, how long was the rocket in the air before hitting the ground? Well, you have to think a little bit. If something is hitting the ground, what would the height have to be? Well, wouldn't it have to be 0? Because it's on the ground, your height would be 0. So when you're asked to figure out how long something takes to hit the ground, usually your height would be 0. You're going to set this equation equal to 0 and solve. So I am running out of time here, so I'm going to kind of rush through this, and you're going to set the equation equal to 0 and solve. So if you look at this, I could factor out the negative 5, and I can try to solve this by factoring. So if I factor out a negative 5, all of these can be divided by 5, so I get t squared minus 2t minus 4 equals 0. But then if I try to factor this, there are no numbers that multiply together equal 4 that have a difference of 2. So that's not going to be factorable. I could get rid of the negative 5 by dividing both sides by negative 5. So that gets rid of that. As long as I don't have a variable, I'm not going to be eliminating any solutions. So